Okay, so here we are solving equations and inequalities. In order to solve equations, you have to follow the rules, right? The rules of math, the rules of algebra. And the properties are the rules. You can do anything as long as it's one of these properties, as long as you do it to both sides. So looking at number one, this example, you see A plus B, right, equals B plus A. And then, or you could use, that's with addition, right? And then this is with multiplication, right? So you look to see, okay, what has changed? Well, here you have A first, right? And A first and B second. And then now they've switched, right? And you have B first. So that would be the commutative property, all right? The commutative property is where the order matters, all right? It's all about order, okay? If you change the order, that's the commutative property. So looking at the next one, well, I've got A first, then B, then C. And then on the other side, you look at the other side of the equation, you've got A, B, C. So did the order change? No. The order did not change. And then here's another example. You can do it with multiplying, right? If they're all stuck together, that's multiplication. So again, you have A, B, C, A, B, C. So it is not commutative. So what has changed? Well, we've got here, A and B are in a group. All right, so you're gonna, and remember PEMDAS, you would add these first and then add that to C. Well, over here, this is saying, if you want, you could get the same answer if you group B and C together. Add them first, and then add A, you're gonna get the same answer. So here you have A and B, and you can do this with multiplication as well, okay? So that would be, has to do with different groups, right? You've got parentheses, and that would be the associative property. All right, and that's only true, this only works for both of these for adding or multiplying. Okay, it is, these are not, it's not there for dividing or subtracting. So let's see, we've got this next one. What we've got is the zero, right? We've got this A, and then we're adding 0 to it. And if we add 0 to the A, we still get A. We didn't change the value of A. 5 plus 0 is still 5. 20 plus 0 is still 20. Okay? And then this is just saying that since adding is commutative, right? If you change the order, if you have 0 plus A, right, you're still going to have A. All right, because adding is commutative, so the order doesn't matter. But what we're interested in here as far as naming the property is that we're adding 0. Okay, and then we ended up with what we started with. We had A on the left and A on the right. Okay, we ended up with what we started with. And then now this is saying, you know what, that's also true if you times by 1. Right, if I multiply by 1, I have my A that I started out with, I multiplied it by 1, oh, and that's still A. A times 1 here. Well, what this is saying, the commutative property, right? Order doesn't matter if you're multiplying. So you can multiply on the left, multiply on the right. It's going to be the same, right, because of the commutative property. So 0 and 1, what would those be? All right, so this is addition over here. So what would this be? Well, this would be the identity, right? You say it has the same identity, okay? Your identity is your identity, and if you add 0 to it, you're still yourself, right? You're still A. If you were 5, you add 0 or multiply by 1, you're still 5. Okay, so this is the identity. That A there has kept its identity. And true for 0 and 1. That's what's special. This is 0 is the additive identity, and 1 is the multiplicative identity. Okay. So now we have the next one. We've got our A, right? And then we're adding the opposite of A. And that ends up with, we end up with our identity. We end up with 0. Okay, so I kind of made that A go away. Here with the identity, the A stayed there, right? I had A on the left and I've got A on the right. Now I made the A go away. I had an A, I added the opposite of A, and now I don't have an A anymore. I've got the identity there. Same thing here with multiply. All right, I had an A, I multiplied by 1 over A, right, the reciprocal, and then now I got that identity. Okay, now this is saying A cannot equal 0, and that's because you're dividing, right? You can't divide by 0. All right, so what property would that be? Where you made the A go away. All right, so that's the inverse property. And that's basically how we solve equations, right? We do the opposite. We make the A go away. We make everything go away till we have our variable, till we have X by itself. We get rid of all. That's how we get rid of the inverse. Is how we get rid of all the numbers and get X by itself. Okay, so now this one, you've got an equation. All right, you're going to compare the left side to the right-hand side, and what is different? Well, the left-hand side has parentheses, and the right-hand side does not. So what would make this go away? Well, also I have, this is a multiplication problem. I have A times this number, B plus C. Over here, so that was A times this, and then now I just have this number plus this number, all right? So how did I do that? I know you all know this property. This is everybody's favorite. The dolphins, oops, there's no dolphins over here. You have your dolphins and you end up with A times B, and then you end up with A times C. Right, so what property is that? That is the distributive property. The distributive property. Now this is one, the next one used a lot in geometry. All right, you said, oh, this side is equal to itself. It's congruent to itself. Right, and what property was that? Reflexive. It's like looking in a mirror, right? That is the reflexive, like you're looking at your reflection. Oops, so I wrote reflect, and then reflexive, right? Okay, so yeah, reflexive, the left side is exactly like the right side. So now if we look at this next one, we've got, here's our equal sign, so I have A on the left. So I've got, oh, A equals B, right? So there's one equation. And then now I've got this other equation, right? And I've got 13 minus A equals 5. Okay, and then I've got this phrase here, this if, right? If A is equal to B and 13 minus A equals 5, then, so another kind of geometry thing, then 13 minus B is equal to 5. Right, I have 13 minus B is equal to 5. So here I had 13 minus A on the left, and now I have 13 minus B. Well, what changed? Oh, instead of the A, we have the B, and we can do that because A equals B. So what did we do? We substituted, right? So is there a substitution property? Yes. Okay, we can do that. Again, these are the rules of algebra. All right, it's just like playing any game. if you just follow the rules and you can do whatever you want. You have whatever strategy. The fun of a game is not the rules, it's the strategy. How do you use the rules to win, right? And to win in algebra, you get the x by itself. Or basically, you simplify your equation. You find that answer that makes it true. So here we go. Now we're looking at this one. This is another if then. So if y is equal to 1, then if I subtract 1 from y, I get 0. So what happened there? What makes this one different from this one? I've got y minus 1 and then 0 here. All right, these were both equations. I have this equation, y equals 1, and it changed to y minus 1 equals 0. Well, I subtracted 1, right? This is the new thing. I've got minus 1 over here. But if I subtract 1 from 1 minus 1 over here, that's going to be 0. Right, so it's kind of like I had y equals 1, and then I subtracted 1, right, from both sides. And so I get y minus 1, because I can't combine those. They're not like terms. But these are like terms. Numbers are always like terms. So 1 minus 1, I can combine that into be a 0. So what did I do? I subtracted from both sides. Okay, so I subtracted from both sides. Alright, so, and again, that's how we solve algebra, solve equations, right? So now I've got this next one, okay, I've got this equation here, 1/4 equals 0.25. And then over here, I have 0.25 equals 1/4. So it's the same numbers exactly, but they're on different sides, right? So if I have, right, this just switched over to the other side. So what property would that be? So that's symmetric. All right, it almost seems like it should be, that's symmetric because it's not reflexive because they're not exactly the same. All right, but they're flipped over. Like symmetrical means the left side is the same as the right-hand side, but it's like looking in, but it's like flipped over, right? It's like looking, if you were to reflect over here, this would be here. And that's why that's kind of, seems like almost like it could be reflective, because this is a mirror. This kind of reflects over here, but it only has one. But it has two equations, right? You have two equations. Reflexive only had one. This equals that. This side is the same as that side. So this has two equations, and it's kind of like reflected, but it's backwards, right? So the order changed. So that would be symmetric. Okay, and then the next one, I got into this a little bit. We've got x equals 1, and so if x is equal to 1, and then we got a new equation. So this was our first equation, right? And then it changed to that. Well, how did it change? Okay, well, you can see right here you got a plus 2, right? So we had x equals 1, and what did we do? We added 2 to it, all right? And what's the rule? You have to do it to both sides, right? So now can I combine x plus 2? Is that 2x? No, because then that's times. If it's x plus 2, that stays as x plus 2 equals, and then 1 plus 2, those are like terms. Numbers are like terms, so you can combine them. 1 plus 2 is 3. All right, so what did I do? Oh, we added to both sides, right? We added 2. So that would be addition. Up here we had subtraction, where we subtracted 1 from both sides, and now we are adding 2. So you can add or subtract both sides. Addition, property of equality. Okay. So now this one, we have 1.5 equals 1.5. All right. Oh, and then also you've got this if, and if this is true, and this is true, then we end up with this. All right, so we have 3 equations. All right, 3 equations. X 1.5 equals 1.5, and 1.5 equals 3 halves. And then we end up, our final conclusion is that 1.5 equals 3 halves. So what happened was we had this 1.5. We ended up with the 1.5 and that equals the 3.5. We got rid of this guy. So what property is that? Where you have this is equal to this and this is equal to that. So these outside things, these other things are equal to each other. Okay, again, these are properties you use. This is logic. Oops. So you use this a lot in your geometry class. So if you have 3 equations there, that's going to be transitive. Like try. Transitive, try. You have 3. You have to use transitive property, you have to have 3 equations because you have to have that link. You have to have this link here, and that requires 2 original ones, and then you end up with the 3rd one. So that would be transitive. Okay, so now we have the last one. We have z equals 4. We start out with, and then we end up with z times 6, right? So we had z equal to 4, right? And then we multiplied it by 6, and we multiplied this side by 6, and I can put them one on the left and one on the right because multiplying is commutative, right? The order doesn't matter. So I multiply both sides by 6. That's a z, so I'll put a little line. So that gives me z times 6 equals 24. And so what did we do to both sides? We multiplied by 6 on both sides. So that would be our multiplication property. That would be our multiplication property. Right, way up here on the left, that's our multiplication property. Because we multiplied both sides on the left. Again, these are the rules to algebra. And then the last one, well, what did we do? We had x equals 10, and then what did we do? We divided by 2. Right? And so that means I had x equals 10. Then I divided by 2 on this side, and I divided by 2 on this side. All right, and so this stays as x divided by 2 equals 10 divided by 2 is 5. So that's how we got that equation. And in algebra, we don't use that so much. You use the fraction. Division is a fraction. So use your fraction bar. Oops. 5 by 2. All right, so that would be the division property. If you divided both sides by 2. All right, excellent. Those are the rules of algebra.